simulation. Good. Now, let me change the code. Let me return some SQ. Can you see it? Just 1 second. I save it, I go back to R. And now I can relaunch my DEoptim. Okay, let me say DE A equal DEoptim linear lower equal let's say 10,000, upper equal 100,000. It should work. In this case, lower and upper are not vectors, are just variables, because we have only one parameter. Let's see. It should go to 0, no? It should find the optimal solution. You can't see below, but I'll show you. You see that we got to 0 for k equal to 80,000. Which is fine, and now it is moving forward because probably it's not stopping because the tolerance on the value of the objective function is too low, so it's reaching the maximum value of loops, which may be 100, something like that. But we got to the solution, and this is the proof of what should happen if the model was perfect. Let's see when it stops. We have 5 minutes more. I think it is 100 probably. There is a way to limit the number of iterations, and usually I put a limit at 20. Let's see what is the limit in this case. It still moves forward, so there is some parameter that needs to be adjusted. But of course, in this case, we see that it's the optimum was reached. So keep in mind that these optimization routines, they stop when there is a criteria for convergence that is achieved. And the criteria usually is imposed on the improvement of the objective function. When they see that the objective function doesn't improve anymore, they should stop. In this case, probably it doesn't stop because the criteria, the step of the improvement is too low. Here we see only 6 decimals, but probably if we could see the other decimals, it's still looking for something to improve. And therefore we should tell him that the tolerance needs to be limited to the first 2 digits. I would say that the tolerance is to be limited to the integer. And if we set the criteria for convergence, and the criteria can be set through DEoptim.control, then we get a final result. And the final result is the best parameter value, the value of the objective function, and also there is some other information that is provided. Okay, it still continues, but okay, now it was 200. of iteration was 200. Yeah.
I remember because my script is not using QoS. So if I try to block it, it's quite not.
So your screen doesn't? I don't understand.
I mean, I uploaded the linear function, and then I try to assign to QoS the simulation.
Yeah.
And then I try to plot it, but nothing here. Plot.
Yeah, there must be something wrong in the code, and I'm sorry that we don't have time now to look at it, but my suggestion is try to understand what's going on, and then if you don't find the answer, then next time we look at it. Questions? No questions. I think in order to close, we need one question.
My only question is when we use the PO, okay, but basically I don't know if there is a better option with respect to the optimum one that I can see. I mean, now because of you, I know about the optimum, but at the beginning I simply go to internet.
Okay. Yeah, I tell you what is my experience. Usually I use the function that is embedded in R, and if I'm not happy for some reason, I try to find an alternative. When I started using Optim, I was not happy. I don't remember for what reason, and therefore I started using this one. And then recently a student told me that Optim was working fine. And then I tried, and indeed I found that it was working fine. So now the only reason why I am keeping to use DE Optim is just to teach you how to upload the functions from the repository. So my suggestion for you is obviously try Optim. The usage is the same. Look at the manual in R and try it. And then you tell me if they are fine. The only thing is if you work with the whole simulation of 8,000 data, it takes a while to converge. And therefore, in order to get convergence, you should change the criteria for convergence. And this requires some time. So it may take some time to try both of them and to wait for convergence. But at least if you don't plot it and you let the PC running during the night, you get to convergence with both of them, even if you don't change your criteria, and then you can make a comparison. And you have to try. That's it. Okay, I think we need to leave the room because the other students are making noise, and it means that they need to get in.